Okay, so here is every single circle concept that you need to know in order to prepare for your SAT math. First one. Okay, the thing about the questions of circles is that most of the students think that they are gonna leave or they're gonna skip the questions of circles in the exam. I don't know, for some reason they feel that circles is a difficult topic, so they think that okay, they're gonna be maximum 2 or 3 questions in the exam, so they decide they already, they have already this thing in their mind that okay, I'm gonna skip those 2 and 3 questions of circles. But trust me, circles is the most easy topic on your SAT math, and basically you can earn free scores. So let's get started with this. First is equation of a circle. So in a Cartesian plane, in a two-dimensional space, everything has an equation. A line has an equation, um, a point has its coordinates, and similarly circle also has its equation. So here I have this circle. Let's say this is the center of the circle, so that means that this is the radius. So in order to fix the position of a circle, in order to define its equation, we need two things. We need the coordinates of its center. So let's say that the coordinates of this center are h comma k, and the radius, the length of the radius is r. So the equation of the circle is given by x minus h whole square plus y minus k whole square equals to r square, where h comma k are the center of the coordinates. Second, angle in a semicircle. So if we have a semicircle, let me draw a semicircle. So this is the diameter, and you can see that I have divided the circle into two semicircles. And then if I draw an angle like this, so this angle is called angle in a semicircle. Or if I make this angle is also inside a semicircle. Or if I make this angle, this is also inside the semicircle. So this second point says that all the angles in a semicircle are right angles. So this one is a right angle, this one will be also a right angle, this one will be also a right angle. This is a really important theorem. Okay, so this is done. Third one is tangent is perpendicular to the radius. Okay, let's see what is this all about. So let's say that this is the center. Now what is a tangent? A tangent is a line that touches the circle. It touches the circle at one point. So this is the tangent, and every tangent is perpendicular to the radius at the point of tangent C. So this is, first of all, what is the point of tangent C? This is the point of tangent C, the point at which tangent is touching at the circle. So this is called the point of tangent C. So a tangent is perpendicular to the radius at the point of tangent C. So this angle, the angle between the radius and this tangent, is going to be a right angle. Fourth one says central angle is twice. What is it twice of? So first of all, let me draw a central angle. So this theorem says that central angle is twice the angle drawn on any other portion of the circle. Let me just show it to you. So this is the center. Now a central angle is an angle which is made at the center. So this is a central angle. Now if I draw any other angle on the remaining portion of the circle like this, you can also draw something like this, or we can have something like this. Okay, so this central angle is gonna be twice, it's gonna be twice of all these angles. So for example, if this is x, this will be also x, which is your last theorem. Angles in a same sector are congruent. So let me cover this as well. These three angles that you see, the white, green and yellow one, these are the angles in a same sector. So angles in a same sector are congruent. That's your last theorem. And the fourth theorem says that central angle is twice the angle in the remaining portion of the circle. So if these three guys are x, then the central angle is gonna be 2x. That's your fourth theorem. Then the fifth concept is of arc length. This is the most important concept in circles. I'll tell you at the end of the video which three concepts are the most important concepts out of these concepts, and no matter what, I can give you guarantee that you are definitely gonna see some questions on those 3 to 4 topics. Okay, the fifth one is arc length. Arc length. So if I randomly take an arc, so I'm taking this arc. Okay, I'm taking this arc and I am interested in finding out the length of this arc. What is this length? Let's say that it's L. So to find out this length, we need two things. We need the angle this arc is subtending at the center. So I need this angle. Let's assume that this angle is denoted by the Greek letter theta. And the second thing that I need is the radius of the circle. If I know these two things, then I can find out the length of the arc. So length of the arc is given by, I'm going to write the formula. Arc length is given by, write the circumference of the circle, which is 2 pi r, times this angle over 360. That's your arc length. Then next you have sector area. Now what if I am interested in finding out what is the area of this center? Imagine that this blue circle is a pizza and you want to find out the area of this slice. So the sector area is given by, you first write the area of the circle, which is pi r square, and you multiply that by the same thing, so theta over 360 degrees. That's your sector area. Then next you have cyclic quadrilateral. What is a cyclic quadrilateral? A cyclic quadrilateral is that quadrilateral whose all the four vertices lie on the circle. So for example, I'm drawing a quadrilateral like this. So all the four vertices, they lie on the circle. First, second, third and fourth. Now the theorem is that opposite angles of a cyclic quadrilateral are supplementary. So opposite angles, let's say that this quadrilateral is A, B, C, D. So A, B, C and D. Now the opposite angles, angle A and angle C, they are going to be supplementary. So that means that angle A plus angle C will be 180 degrees, and the next pair, this angle B and angle D, they are also going to be supplementary. So angle B plus angle D is also going to be 180 degrees. Finally, the last one says perpendicular drawn from the center bisects the chord. Okay. So if you have, this is really important, if you have a center and there is a random chord, you just draw any random chord. Let's say this is a chord, and you draw a perpendicular from the center to the chord. You draw the perpendicular from the center to this chord. So this theorem says that this perpendicular will bisect the chord. So this length is going to be the same as this length. So if this is A, this point is B, this point is C, so we have AB is same as BC. So this covers all the concepts which can be asked in your SAT math, but there are different types of questions that can be formed from these concepts. So now I'll tell you that which of these are the most important ones. You can definitely expect, you can 100% expect a question from the first one, equation of a circle. Then expect at least one question from either arc length or sector area. One question will be there from one of these, and you can expect one question from inscribed angles property, either this one, central angle thing, or the last one. So that's it for circles. Thank you so much for watching.